All right, you should be ready to check your warm-up. Number 1, we're writing the equation in logarithmic form. So the first thing that means is we have to have the word log. We look for the base, which is the 3, and we're talking about the 3 here. Then we have the answer, which is 27, and it's equal to the exponent. Number 2, we're writing it in exponential form, so we're doing the opposite. So we again start by looking for the base. Base of a log is always that small number. So 7. The exponent is always on the equal side. And the answer in this case is 49. So there are your 2 answers for 1 and 2. Hopefully doing good so far. Looking at questions 3 and 4. So now to evaluate, this is what we just worked on yesterday. So we're going to set it equal to x. So we write 4 because that's the base. X is our exponent, and it's equal to 64. So the question is, 4 to what power is 64? And that would be 3, because 4 times 4 times 4 is 64. Number 4, same direction. So first thing we do is we set it equal to x. Now here, there isn't a base number. Well, remember, whenever there's no base number, it's like having that invisible 10 there. And then the x is our exponent, and it needs to equal 100. So 10 to what power is 100? And that would be x equals 2, since 10 times 10 is 100. And there are your 4 answers to the warm-up. Here are your questions from homework last night. I know they were a little bit harder because they were fractions or decimals. Most of them won't be that way. Number 30, x would have been 1.5 or 1.5 or 3/2. Number 31 was 2.6 is fine, or 2 2/3 or 2.6 repeating. And number 32, either -2/3 or -0.6 or negative repeating or -0.6. The biggest thing here on number 32 is since the base was turning into a fraction, we knew it had to have a negative. Okay, so hopefully at least it had a negative there. The fractions or decimals I know are a bit harder than what we covered. But again, if you could also do the warm-up today, then you're probably doing pretty good. Today we're going to talk about properties of logarithms. Logarithms, we kind of consider them to have their own log world, and there are certain things that happen in log world. We use these properties to help us either to simplify or expand in order to evaluate logs. So the first property is the product property, and that says that you can switch between addition and multiplication. So if you have 1 log of base b where the 2 numbers are being multiplied, then that means you could simplify them or expand them into 2 logs by addition. So sometimes it doesn't help us to have 1 log with 2 things being multiplied because I can't simplify it any, but I might be able to simplify it or evaluate it if I broke them apart. Or vice versa, maybe we have this, and it would be easier for us if we have this. So we can switch between adding 2 logs, which is the same thing as multiplying them together in 1 log. Well, the next property we have is the quotient property. The quotient property says we can go from subtraction to division. So much like the plus and the minus, or the times, this says if I start out with a log and the numbers are being divided, then it's the same thing if I expand and have the two logs being subtracted. The last property we have is the power property, and this says that if I have a log of base b and m is raised to the nth power, I can write that as n times the log base b of m. So this is what we call expanding or simplifying the logs. And we do this again in order to evaluate. Sometimes we can only evaluate them when we get down to certain answers. So simplifying expressions, we're going to write each expression as a single logarithm. So we're going to condense them together. And to do that, we're going to use the properties of logarithms, which are the three that we just saw up there. So if I look at the example of log 432 minus log 42, the first thing is the bases do have to be the same. So we can only put them together if those match. So since this is starting off as subtracting two logs, I know that if I'm subtracting two logs, it's the same thing as writing that log with a division problem. So we keep the log base 4, and it's 32 divided by 2, and it goes in order since the 32 came first. Well, I know what 32 divided by 2 is. 32 divided by 2 is 16. So I know that the log base 4 of 16 is the same thing as that subtraction problem. And there's my simplifying it. So go ahead and try the U-try problem on the right. And then unpause this after you've checked your answer and then with a neighbor and then checked it with the video. So with this one, it's an addition sign in between the two logs. The bases do match. So I want to write it with one log, and addition in log world means that I could switch it to one log with multiplication. So this is going to be 9x times 3x. Or maybe you wrote them with parentheses. Either way is fine. Well, 9 times 3 is 27. And x times x is x squared. So this one simplified to log base 4 of 27x squared. Now let's look at a slightly harder one. Here we have numbers being multiplied on the outside. And we have addition going on. Now the first thing is, remember, when I have multiplication written on the outside, then I can change that into the exponent of what's inside the log. So let's go ahead and do that first. So I'm going to rewrite the first log as log base 2 of x, and it's going to become to the 6th power, because the 6 being multiplied is going to go to that exponent. And then the second exponent, or the second log, I'm going to do the same thing with that 5. So I'm going to go log base 2 of y to the 5th. Well, now I know that if I am adding two logs, that's the same thing as putting them together by multiplication. So we have log base 2, and it's going to be x to the 6th times y to the 5th. If you put a multiplication sign in between them, that's fine, but you don't need to, because we know that when you're multiplying two variables together, you just keep them side by side. So now go ahead and try your U-try problem. check with the neighbor as you go through it, and then unpause the video to check your answers and make sure you're correct. So I'm going to do this one in 2 steps again, since we've got a number on the outside here. So this number on the outside being multiplied, it's going to go and become the exponent. So this becomes log 4 of 6 squared. Well, I know what 6 squared is. That's 36. So this is actually log base 4 of 36. Now on the second log, there's no number on the outside, so this is just going to stay minus log base 4 of 9. And I know that minus in log world means I could switch it to division. So we have 1 log base of 4, and 36 divided by 9. Well, I know what 36 divided by 9 is. That's 4. So this means log base 4 of 4 should be your final answer. Now, the one thing with this one, and again, if you left it as that, that's absolutely fine, but let's think about this. Notice how these two numbers match, the base and the answer. Well, when that happens, this means it's actually equal to 1. Just like if it's 4 over 4, you automatically write it as 1. If you see that the base and the answer match, then really and truly simplified goes all the way down to 1. But that was an extra catch on that one. So now we're going to do the opposite. And instead of simplifying, we're going to expand them. We're still going to use our properties of logarithms. So we're looking at all of our, since we have single logs here, we're expanding them. So every individual piece that you see in the problem needs to have its own log. So for example, this 4 is going to have a log, the x will and the y will, each piece. So I know I'm going to have log, and they all have the same base. Since there's no base listed, that means that base of 10, so I'm just going to leave it. So I have log 4. Well, log 4 is being multiplied by x. So in log world, I can switch that multiplication to addition. So that becomes log x. And then it's being divided by y. Well, since both parts are being divided by y, I'm going to put parentheses around here. And I know that in log world, I can switch from division to subtraction. So minus log of y. And there it is in expanded form. So again, the biggest thing to remember is any little piece that's in there is going to have its own log. Now we're going to talk really quickly about the u-tri, and then you're going to finish it off. The u-tri has some exponents, and we didn't talk about exponents in our example here. But property in log world says if the number was on the outside, I could write it as an exponent, which means if I have an exponent, I can switch it to come out front. So log of m squared, the 2 is going to go to the front to be multiplied, and then m. Now go ahead and do the rest of that. Remember, each individual term or piece has to have its own log, and then unpause this when you're ready to check. Alright, well, we already took care of the m squared. M squared is being multiplied by n to the 4th, which means we're going to switch it to addition. The exponent of 4 is going to come out front. So this becomes 4 log of n. Now, both pieces are being divided by. Well, divided by means subtraction, so I'm going to put a minus sign here. It's going to be minus log p. But p is not the only thing in that denominator. There's also a q to the third. So we're going to have another set of parentheses here. So log p, since it's being multiplied by q to the third, that's going to mean addition. The 3, since it's an exponent and we're expanding, it's going to come out front. And then log of q. And again, the biggest thing is you do need to have parentheses around the first part and around the second part, because you want all of this being subtracted by all of this. Our next example deals with some square roots. Now, there might be something new here. If there is, we'll try to make it understandable. If not, then we should be good to go. First of all, we have s times the square root of 7. So I have log, because we're expanding, of s. It's being multiplied by the square root of 7, so that means we're going to change it to addition. And square root of 7, I can actually change that. The square root of 7 is the same thing as 7 to the 1/2. And we know that because the square root of 7 means there's a 2 here. Since 7 is all by itself inside the radical, it means that it has an exponent of 1. So that 1 goes to the top and the 2 comes to the outside. So I can write this as 7 to the 1/2. So if I had a cubed root, then it would be a fraction with the third. A fourth root would be a fourth, and so on. So all of this is being divided by t squared, which means minus. The 2 on the exponent of t is going to come to the front. Now I still have an exponent here that I need to take care of. Any exponents go to the front and to be multiplied. So I have log of s plus 1/2 log of 7, and that's still in parentheses, minus 2 log of t. And there's my final answer. So now go ahead and try the next one. The biggest thing to remember on this one is that that is 4 times the square root of 4r over s squared. It's not the fourth root. That 4 is being multiplied. So go ahead and give this one a try. I know it's a little hard. Do your best on it, and then we'll check it in just a second. So unpause the video when you're ready to check the answer to the last you try for today. Alright, well, we know that the log 4 is going to come first. Since it's being multiplied, we're going to put an addition sign here. Now, the next big thing is 4r and s squared are all inside that square root. Well, remember we said the square root we can write as an exponent of a half. So I'm going to put 4r log of 4. It's then being multiplied to r, which means we're going to expand that to addition and log of r. And then it's being subtracted by, since it's division, s squared. Well, when I put s squared in log form, the exponent's going to come to the front. So 2 log of s. And all of that is inside the 1/2. Well, that 1/2 of an exponent needs to come out to the front. So we're going to have log 4 plus 1/2 times all of this. your homework tonight is to go ahead and complete the first 6 problems you see on this set of guided notes. It's not in that packet that you got. It's going to be these 6 problems. Tomorrow we're going to learn something new, and then your homework will be on all of these skills from 4-4 in that packet. So again, you're working on 1 through 6 tonight for homework.